We have to give the acceleration of the different blocks. In case A, if I consider case A over here, we have to simply find out whether the static frictional force is greater than the force applied. If it is greater than the force applied, if the maximum static force is greater than the force applied, the block will not move and the acceleration will be 0. So let us calculate for the block A. For in the first case, the static force or the static frictional force will be equal to mu mg. So mu is given as, the static force is given as 0.5, mass is given as 5 into 10. If I calculate this value, it will be equal to 25 Newton. Now clearly the static force is smaller than the force applied. Okay, so the force that will apply over here, that is the kinetic force, okay, or the kinetic frictional force. So now this force is acting in the right hand side direction, kinetic frictional force will act in the opposite direction. So 40 minus Fk will be equal to mass into acceleration. So 40 minus mu k into mg will be equal to ma. Now mu k is equal to 0.4. So 40 minus 0.4 into mass is 5 into g is 10 is equal to mass is 5 into acceleration a. Okay, so 40 minus, this will give me the answer as 20. So 20 divided by 40 minus 20, that is equal to 20, is equal to 5a. So in the first case, acceleration will be equal to 4 meter per second square. Okay, this is the acceleration in the first case. Let us find out the acceleration in the first case is done. Let us find out the acceleration in the second case. The same thing we will do, apply over here. But before we proceed with this part, we have to resolve the normal forces. Okay, the normal force over here will be equal to 50 cos 37, that is cos 37 is equal to 4 by 5 in this direction, 50 sin 37 in the upward direction. Okay, 50 sin 37 in the vertically upward direction. Okay, and mg, that is the 10g in the downward direction. There will be a normal force which acts in the upward direction. So in this case, the normal force is given by, in the second case, that is for block B, the normal force will be equal to normal force plus 50 sin 37, normal force plus 50 sin 37 is equal to 10 into g. Okay, this will be the normal force. Okay, this will be the normal force. Now over here 50 n will be equal to 10 into g, which is equal to 100 Newton. Okay, minus 50 into sin 37. Sin 37 is equal to 3 by 5. So it will be equal to 30. Okay, it will be equal to 30. Now the normal force over here is equal to 70 Newton. Okay, 50 100 minus 30, which is equal to 70 Newton. Okay, so the frictional force, the static frictional force is equal to mu into n, the normal force. So mu over here is static force is given as, static frictional force is 0.5 into 70, okay, which is equal to 35 Newton. Now the static frictional force is equal to 35 Newton. Let us see the force acting in the right hand side direction. In the right hand side direction, 50 into 4 by 5, which is equal to 45. Okay, so in the right hand side direction, the force is little greater. Okay, so we have to apply the kinetic friction. Again, the static force is smaller than the force applied, so we have to apply the kinetic friction. So 40, that is the force acting in the right hand side direction, minus Fk is equal to ma. Okay, which is equal to ma. So 40 minus Fk, the kinetic friction force is equal to 0.4 into normal force is 70, is equal to mass is given as 10 into acceleration is a. So 40 minus this will give me 28. Okay, so this will be 12 is equal to 10a. So acceleration will be equal to 1.2 meter per second square. Okay, this will be the acceleration in the second case. Similarly, for the third case, mu s and mu k both are equal. Okay, let us calculate the frictional force which acts in the opposite direction. In the third case, that is the case number C, that is in case number C over here, it will be equal to the frictional force will act in the opposite direction, which is equal to mu mg. Okay, which is equal to mu mg. So mu is given as 0.6, m is given as 10, g will be equal to 10. So if you calculate this value, it will be equal to frictional force acts in the opposite direction, which is 60 Newton. If I see the maximum tension that acts in the 5 kg force, okay, or the 5 kg body, it will be maximum force that can be applied in the downward direction will be equal to 5g. Okay, that is the maximum force in the downward direction is equal to 50 Newton. Now since it is smaller than the frictional force, this force cannot overtake or cannot drive the 10 kg force in the right hand side direction. So the acceleration of both the blocks in this case will be equal to 0 meter per second square.